Okay, so now we can start talking about these cost revenue estimations that we're going to use to kind of determine what our costs or revenues may be in the future, right? We're going to use historical data to kind of configure and compile that and make estimations. So we use that historical data to create linear relationships. It allows us to kind of predict future cost and revenues. And if you watched the prep videos, you'll know that some of the principles that we use, some of the assumptions that we make about what makes useful information. One of those things is that it's predictive, right? That we can predict future behaviors based on the information that we have. And we'll be doing that with these cost revenue estimations. So first one we'll talk about is the cost formula. And all it says is that your total costs equals your fixed costs plus your variable cost times your activity level. Revenue formula is the same, except replace your costs with revenue. So total revenue equals your fixed revenues plus your variable revenue times the activity level. However, please remember, these are only valid within the relevant range. These are only relevant when they're inside within the relevant range that we determine. So the method that we're going to use in this class to make these estimations is what we call the high-low method, okay? So the high-low method, we're going to use two data points to determine the total cost or revenue, and then we're going to define the relevant range, right? So that relevant range, the definition of that relevant range is the low to the high. Anything within that range is the relevant range. So if we if the lowest number of sales we had for the month or for the year, was $120,000 in June, and our highest was $426,000 in September, that's our relevant range, $120,000 to $460,000, whatever the case is. Okay, so that is how we're going to determine what our relevant range is. Very simple. Okay, so we're going to take the highest level of activity driver. We're going to grab the lowest level of the activity driver, and that is our relevant range. Okay, we represent that with our formula that we learned earlier, y equals a plus b times x. This is our book formula, right? Where y equals the dollars, our y-axis, a is our y-intercept, b is our slope, our rise over our run, and x is your level of activity, or the x-axis, okay? Now, we can determine the slope using the slope-intercept formula, that y equals mx plus b. We've learned this in math classes since we were in middle school, so we should be somewhat familiar with this formula, okay, where y is our dollars, again, m is our slope, x is our activity, and b is our intercept, okay? So, for instance, we have dollars equals our y-intercept plus our slope times our activity, okay? The y-intercept is your fixed cost. The slope is your variable cost per unit. And slope, again, is your rise over your run, which is your dollars over your activity. So rise equals your cost in dollars, run equals your activity. So here we finally see total cost equals fixed cost plus variable cost per unit times activity, which is the formula we just talked about on the previous slide. So there are some steps to computing the high-low method, right? So the first is we want to find the highest and lowest levels of activity. Then you're going to determine the total cost of each level, high and low. And once we do that, you can kind of see now that the high and low points are based on activity, right? Then we're going to calculate the variable cost per unit by dividing the cost, or the rise, by the change in activity, the run, to find the slope. Remember that rise over run is going to be your highest cost minus your lowest cost divided by your highest activity minus your lowest activity. That is going to be your slope. Okay, so we will use that formula when we go through an example here in a moment. So finally, you are going to determine the fixed cost per period using either the highest or lowest level activity. Make sure that you use one of those, not both of those. You want to make sure, typically in our examples, we're just going to use the lowest level of activity. So again, we can go and we say, okay, our total cost is our fixed cost plus our variable cost times our lowest level of activity. Okay, said that a lot, but just follow this process. Okay, and then the variable and fixed costs can be used once we find them to determine the future costs by plugging in an estimated level of activity within the relevant range. So we could say, hey, how much are our costs going to be if we decided to produce 75 units this period? Okay, so next we're going to walk through a quick example here. Okay, so Prairie Plants collected data over 7 months about the total cost and number of plants delivered. Given this, what would our relevant range be? Okay, so we can look here and we go, how do we determine our relevant range? Well, we find the highest and the lowest. What was our highest? It appears to be May of 70, and our lowest was in February of 10. Okay, so let's find the cost equation. $1,310, that's 70, right here, minus the $650, so your highest minus your lowest, divided by your highest minus your lowest activity, equals $11 in variable cost. Now we have found our variable cost. We can plug that in. So we know now that $650 equals our fixed cost plus our level of activity time, our lowest level of activity times our variable cost. Okay, so that tells us that $650 equals our fixed cost plus 110, which tells us that $540 is our fixed cost. Now we can fill this formula out, right? We can prove that this formula is true. $650, our total cost, equals $540, our fixed cost, plus $110, which is our variable cost. Now we've proven that formula. So now we can go ahead and use those fixed and variable costs to kind of determine activity in the future. So what would the total cost be if they were to sell 38 plants? Well, we would take our total fixed cost, we would take our total cost, and we know that that equals our fixed cost plus our activity times our variable cost. Let's fill in what we know. So our total cost in this instance is going to equal $540 because we know that's our fixed cost, plus the level of activity times our variable cost, okay, per unit. So we know that our total cost is now $958 if we were to produce 38 plants or sell 38 plants. Now, what would the total cost be if they were to sell 99 plants? It's kind of a trick question though, right? The answer is that the 99 units is outside of our relevant range, so it would not be a valid estimate. It's not a level of production or a level of sales that we've met in the last 7 months, so we can't really say that it's relevant. Our relevant range, once again, is 10 to 70 units. 99 is outside of that relevant range, so it's not valid. Okay. So the next video you'll see will be me walking through an example of this that'll be similar to something you'll see on your homework. So if you got any questions or comments, please reach out to me and let me know.